In this video, we are discussing Python arrays implementation. Arrays are fundamental part of most programming languages, and it is the collection of elements of the same data type. As example, you can go for array of int, array of strings and so on. So here we are having the methods which will be operated on these arrays, and here we are having the respective functions and descriptions. So append, to add element to the end of the list. Extend, to extend all elements of a list to another list. We are having this insert, to insert an element at the another index given. So remove, to remove an element from the list. So pop, to remove elements, return element at the given index. So that means in case of pop, to remove elements and return that element which has been removed from the given index. We are having clear, to remove all elements from the list. So the list will become empty, the array will become empty. Next one is the index, to return the index of the first matched element. So that is useful for the searching. We are having this count, to count the number of elements passed to an argument. So next one is our sort, to sort the elements in the ascending order by default. Next one is the reverse, to reverse order elements in a list. So the order of elements whatever will be there initially, that will be reversed in after application of this reverse method. Next one is the copy, to return a copy of the elements in a list. So these are the different methods and the respective functions we have discussed. So I think it would be better if you go for a demonstration. There will be executing our Python codes to show you that how this array can be used in our Python programming. Arrays are fundamental part of most programming languages, and it is the collection of elements of a single data type. And as example, we can consider array of elements like string, array of integers, array of float and so on. However, in Python there is no native array data structure, so you use Python list instead of an array. But if I want to create a real arrays in our Python, we need to use the NumPy's array. That is the data structure we are having in our NumPy module. So for mathematical problems, NumPy array will be more efficient. So unlike arrays, a single list can store elements of any data types and does everything an array does. So we can store an integer, a float and a string instead of inside the same list. So it is more flexible to work with. So let us go for the descriptions and the detailing about this array handling. And at first we are going to discuss how to create one array in our Python. So here we have defined one array. So definition and declaring an array. So these are the set of elements it is having, and print ARR. So it will produce the output like this one. So now if I want to access our array elements, we can use the index. The first element will have the index 0. So ARR 0 will print 10, ARR 1 will print 20 here. So ARR 2 will print 30 here. And here we are having this ARR minus 1, that means the last element will be printed, that is our 50. We are having this ARR minus 2, so that is minus 1, this is my minus 2, so 40 will get printed. So here we are using negative indexing. So now let us go for another array here. So here all these members, all these array elements are of the type string. So if we print these brands, we are getting the output like this one. So finding the length of the array, we are having the method, that is the inbuilt method, that is our len here. So len brands, so it will print, it will return 5 here because we are having 1, 2, 3, 4, 5 elements. So if you print a number of brands, we are getting here 5 as output. We can also add some element using the method append. So brands.append intel. So if you go on printing brands, I'm getting this intel as the last element which has got appended to the existing array, that is our brands. So now how to remove elements from an array. So to remove elements, we are having the method like remove, we are having the method like pop. So here we can find that we are having this colors, it is defined there. So let me print the colors here. So going for print colors. Okay. So now if I print these colors, this particular array, we are getting the outcome like this one. So that is the colors I have printed. So now if you go for this del color 4, then after removing this del color 4, if I print,
then the outcome will be this one. So that is the colorful, means we are having this 0, 1, 2, 3, 4. So yellow will get deleted because here we have mentioned the index as 4. So now we are having this colors dot remove blue. So here I'm just mentioning directly the respective data items. So here we are mentioning directly the data items. So that is our blue. So blue is the member of this particular array. So blue is going to get deleted. So you can find that the blue has got deleted here. So now we are having this colors pop 3. So now here we are mentioning the radically the index we are mentioning. So you can find here that is 0, 1, 2, 3. So orange will get deleted, and in this way I'm getting the reduced number of elements of this array getting printed using print colors. So in this way we can remove items from an array. So now we are going for this modifying elements of an array using indexing. So fruits, apple, banana, mango, grapes and orange, we are having this one. So fruits 1, so I'm just assigning pineapple to that. Now what is the outcome? So let me go for the print. So now let me go for the execution. You can find that at first this particular array has got printed. Now fruits 1 means 0, 1. So banana will be replaced by pineapple. So it has got replaced. Now fruits -1 means the orange, the last one, will get replaced by this guava. So we are getting the updated content of this array fruits. So now we are going for the concatenation of two arrays using the plus operator. So concat is equal to 1, 2, 3 and then concat plus 4, 5, 6. So now we are going to print concat. So now let me go for the printing here also. So if I go on executing, we can find that at first we are having this 1, 2, 3 and then after concatenation I'm getting this 1, 2, 3. Why? Because I didn't assign this concat. I didn't assign this concatenated items into the array variable. So now let us write this one. So let me do some changes here. So now if I execute, I can find that. So now this concat has got updated by concat plus 4, 5, 6. So this plus is actually denoting the operator to do the concatenation between two arrays. So now when you are printing this concatenated array, we are getting this 1, 2, 3, 4, 5, 6. So now we are going for the repeating elements in an array. So let us go for this repeat A, and then repeat is equal to repeat star 5 and then print repeat. So now what is the outcome? We can go for this print. So just executing the same. So at first A is there and next time repeat is equal to repeat star 5. So this A has got repeated for 5 times. Okay. So now we are having this fruits. So we are having the set of elements are there. So if I go on executing this, so at first we are getting this fruits, this particular array has got printed. Now print fruits 1:4. Always remember the starting index will be inclusive and the ending index will be always exclusive. So that is the index number 0. Index number 1 is this one. So 1, 2, 3. So I'm expecting banana, mango and grapes should get printed. Yes, they have got printed accordingly. Here the starting index is missing. So it will be considered as 0. So from apple, so 3 means it will proceed up to the index number 2 because 3 will be exclusive. So 0, 1, 2. So apple, banana and mango should get extracted and should get printed. Apple, banana, mango have got printed. So now it will start from this -4. It will start from this -4. So -1, -2, -3 and here we are having this -4 and the ending index has not been mentioned. So it will go printing up to the last element. So banana, mango, grapes and orange, they have got printed. So here we are having this -3 to -1. So -1, -2, -3, I'm getting here mango, and -1 will be always exclusive because it is the stop index. So that's why it will print up to -2, that is our grapes. So in this way we can have the slicing of an array. Okay, so now we are going for the next one. So here we are going to have our multi-dimensional array. So in case of multi-dimensional array, you can find that we are defining one array. So here the first element is another array that is consisting of 1 and 2. The second element is also another array consisting of 3 and 4 and so on. So if you go and print this multi-dimensional array, you are getting the outcome like this. But if you print this multi-dimensional 0, that means this 1, 2, this 1 to this array will get printed accordingly. 3 means 0, 1, 2, 3. So the 7 and 8 will get printed. So multi-dimensional array 2 comma 1. So 2 and 1, they are enclosed within the square brackets individually. So 2 means 0, 1, 2. So 2 means this one, and 1 means 0, 1. So 6 will get printed. Similarly for 3 comma 0. So in case of 3 and 0, they are individually enclosed within the square brackets. So 0, 1, 2, 3, that means this particular element and its 0th one. So 7 will get printed here. So in this way, we have shown you that how to handle arrays in our Python programming with demonstration and example. Thanks for watching this video.
We are going to discuss Python iterators. So iterators are present in Python and they are mostly implemented within for loops, comprehensions, generators, etc., but hidden in the plain sight. So iterator in Python is simply an object that can iterate upon an object which will return data or one element at a time. So this iterator will be operating on a sequence of elements, and each and every iteration it will pick up one element at a time. So iterator in Python is simply an object that can be iterated upon, an object which will return data one element at a time. Technically speaking, Python iterator object must implement two special methods. So what are the two special methods? That is underscore underscore iter underscore underscore method and underscore underscore next underscore underscore method. So iter method and the next method collectively called the iterator protocol. So iter method, that is, it will retrieve the respective value, and the next it will check whether the next element is there in the sequence or not. So an object is called iterable if we can get an iterator from it, and most of the built-in containers in Python like the list, tuple, strings, etc. are iterable because we can get iterator from it. The iter function, which in turn calls the iter, that is the underscore underscore iter underscore underscore method, returns an iterator from them. The next, that is the underscore underscore next underscore underscore method, must return the next item in the sequence. On the reaching at the end and in the subsequent calls, it must raise stop iteration. So whenever we are having no item in the iterator remaining, but if I are calling this underscore underscore next underscore underscore method, then one exception will be raised, and that is a stop iteration. So let us go for one practical demonstration to show you that how this Python iterators can easily be implemented in Python coding. So here is the demonstration for you.
Iterators are very common in our Python programming language, and they are elegantly implemented within our for loops, generators, comprehensions, etc., but hidden in our plain sight. An iterator in Python is nothing but an object, and this object will return data one at a time during our iteration. Obviously, if some data is available, then only it will return the data, otherwise it will throw some exception. So technically speaking, Python iterator object must implement two special methods. One is the next method, so can also be called as underscore underscore next underscore underscore method, and another one is the iter method, that is actually underscore underscore iter underscore underscore method, and collectively they will be known as the iterator protocol. An object is called iterable if we can get an iterator from it. Most of the built-in container in our Python, like our string, like our tuple, list, they are nothing but iterables. The iter method or the iter function, which in turn call the iter underscore underscore iter underscore underscore method, returns an iterator from them. So let us go through this example and to discuss the property of this iterator. So here you see, here we have defined one list here, and this iter method, from using this iter method from this list, we are getting one iterator, and to access the data from this iterator we are using the method next here. So either you can use this next our iter, so this is the syntax to retrieve elements from this iterator. There is a our iter. Otherwise, we can write our iter dot underscore underscore next underscore underscore method. So anyone we can use that one. So here you see the list is containing data that is 44, 77, 11 and 33. So for the first next I'm retrieving 44. Next I'm retrieving here is 77. Next element which will be retrieved here is 11. Next element which will be retrieved here is 33. So now we have got all the 4 elements. Now if we go for next our iter, it will raise one exception. So let us go for the execution of this block. So here we are having 44, 77, 11 and 33. Because the elements were 44, 77, 11 and 33. So when we executed print next our iter, then 44 was retrieved, and next print next our iter, when you execute this method, then 77 has been retrieved from this iterator, that is our iter. Next time 11, next time 33. Now if I execute this one, I should not put this one in comment. If I execute this one, then one exception will be there, and that is a stop iteration, and this will raise error no items left, as we mentioned in the comment. And so next our iter will produce this error, that is a stop iteration. So let us go for another one. So create a custom iterator. So here we are defining one class, that is the power of 2, and here we are having this documentation string. In short, we can call it as doc string. So it should be enclosed either within triple single quotes or triple double quotes. So it is also known as a block comment, and it should be the first intended statement in our class. So next we are having this constructor, that is our underscore underscore init underscore underscore. So here we are defining this max, and this is equal to 0 is the default argument. So whatever the value will be passing, that will be assigned to this max instance variable. So here we are just defining this underscore underscore iter underscore underscore method, and similarly this underscore underscore next underscore underscore method. So these two methods we are defining here. So self.n is equal to 0. So n is another instance variable, is getting initialized with the value 0. And then we're having this next. So if self.n is less than equal to self.max, then result is equal to 2 star star, that is 2 to the power of self.n. So 2 to the power of n will be assigned to the result, and self.n will be increased by 1, and the result will be returned. Otherwise, in the else part, we are going for stop iteration. We are erasing this error. There is a stop iteration. So now here at first we are going to print this doc string, that is a documentation string enclosed within triple single quotes, can also be enclosed within triple double quotes. So whenever we are printing this this one, there is a power of 2, that is a class name dot underscore underscore doc underscore underscore. You can see that it is printing. Let us go for this. It is printing this respective string, that is a class to implement an iterator of powers of 2. So the string whatever is discussed or defined here, so it has got printed. So now we are going for this a is equal to power of 2 4. So now this 4 will be assigned to max. This 4 will be assigned to max. So max has got the value 4 here. So now we are going for this I is equal to iter a. So we are going for this next I, next I, next I. It is going on printing, that is 2 to the power of 0, because n is having the initial value 0 here. So 2 to the power of 0, the result will become 1, and return result, so that result will be printed as 1. So next time this n has got increased by 1. So 2 to the power of 1, the result will have the value 2, and return result, that means it will return the value 2 here. So 2 is getting printed because we have called this next I from this print method. So now next time the value of n will become 2. So 2 to the power of 2 will become 4. So result will have the value 4, and the result will be returned, and that will get printed. So in this way I'm getting this one as 1 2 4 as output. So I think you are getting this idea how this method, which is having this init, that is a constructor, this iter method, the next method, and the respective object we have defined under the class, that is our a. So this max has got initialized with the value 4, which has been passed as the parameter to this constructor. Then out of this a, we are creating one iter. So there is the iterator is this one I, and from iterator we can pick up the next values. So there is a next of I. So this method is getting called. So we can also call it as I dot underscore underscore next underscore underscore method. So let me print it here. So I dot underscore underscore next underscore underscore method. So in this way also we can print it. So now let me go for the execution of the same. So I'm just erasing this part, it is not required. Okay, so now if we execute the same, I'm getting the same output because next I is actually executing I dot underscore underscore next underscore underscore method. So next we are going for creating a infinite custom iterator. So in this case, this is our doc string. The name of the class is infinite iter, and this here we are having this method iter we have defined, the next we have defined. So this is the infinite iter object. The class object is I. From this I we are creating one iterator using the method iter, and then we are going for this next a. So here you see the num has got the value 1. So num is equal to self.num. So num has got the value 1 here. Self.num is plus equal to 2. So in this way it will go on creating, because there is no logic is there to stop this one. It will go on creating, just incrementing this value of num by 2 each and every time, and then returning the num, that is the previous value of num will be returned. So now we are having this next day, the next day, next day. In this way, if you go on calling the next method, so at first the num was having the value 1. So this 1 will be assigned to num, which will be returned. So that is getting printed. So 1 will get printed, then 3, then 5, then 7. In this way, the values will go on printing. So it has got no terminating logic. So that's why it is infinite iter. The name of the class has been given accordingly. So from this demonstration, you are getting this idea that how this iterator can play its role in our Python programming. Thanks for watching this video.
Python operator overloading. So what is operator overloading? Let us discuss that one at first. So Python operators work for built-in classes, but some operators behave differently with different types. For example, the plus operator will perform the arithmetic addition when two numbers will be given. The same plus operator will merge two lists and concatenate two strings. So depending upon the input argument type, the operator will have the different purposes, different operations are getting carried out, and that is known as operator overloading. So this feature in Python that allows the same operator to have different meaning according to the context is called the operator overloading. So here we are having a list. Just see here. Addition, we are doing P1 plus P2, say. So actually internally the function which is getting called is P1 dot underscore underscore add underscore underscore, and then within bracket, that is input argument is P2. So here we are having this subtraction. So that is P1 minus P2. We are having this one as P1 dot underscore underscore sub underscore underscore as input argument P2. So here we are having the list. You can easily check them that we have given the operators, then the expression, and internally which method, which operator overloaded method is getting called. So that has been listed in this table in the third column. So here we are having this less than. So here we are having this comparison operator overloading in Python. So previously we are having this operator overloading special functions in Python. So now if you consider the comparison operators, so that is our less than equal to, double equal to, that is a not equal to. Here we are having this greater than equal to, we are having. So less than, that is a greater than or equal to, and so on. So these are the operators, these are the expressions, and internally which function is getting called, we have listed that one in the third column. So let us go for one practical demonstration on this concept, that is operator overloading, for your better understanding. So here is the demonstration for you.
In this session, we are going to demonstrate and illustrate operator overloading which has to be done in our Python programming. We have defined one class, that is the name of the class is myPoint. We know that here you will be considering a two-dimensional point which will have two coordinates x and y. So this is our constructor, and instance variables self.x and self.y will get initialized with the input parameters x and y. These input parameters x and y will have its default arguments, that is 0 and 0. We are also overriding one method, that is underscore underscore str underscore underscore. This very method will be executed whenever we are going to print object under the class myPoint. and it will return one string which will have x comma y only. You see, we have just generated one string here, and that will be returned. We are also overwriting one method. This is known as the overloading, that is plus operator. So this plus operator, here you see we have defined one method, that is underscore underscore add underscore underscore. So this method will take one object, that is the other, as input, and it will do the addition in this way. Self.x, that is the instance variable x, and other.x will be added. Self.y and other.y will be added. They will be assigned to x and y, and then the object will be returned with this particular, which will be defined with this particular constructor my point, keeping this x and y as input argument. So actually we are calling the constructor of the class my point with x and y as input arguments here. Next, we are going for the overloading of this less than operator. So here in case of overloading, we are just defining one method, that is underscore underscore lt underscore underscore. It will be having the self and the other, that is the another my point class object as input argument. So how we are calculating whether it is less than or greater than. So it will be calculated in this way. You see, self.x square plus self.y square will be calculated, and that will be assigned to self underscore magnitude, and then other dot x square and other dot y square will be calculated, and then the sum will be kept in other underscore magnitude. So now we shall return self underscore magnitude less than other underscore magnitude. That means it returns a boolean if self underscore magnitude is lesser than other underscore magnitude. In that case it will return true, otherwise it will return false. So this underscore underscore lt underscore underscore method will return one boolean. So here we are overloading this plus operator, here we are overloading the minus operator, minus less than operator. Okay, so now we have defined two objects, that is p1 and p2 under the class my point, and here you see this p1 and p2 under the point my point. Here we have passed this x and y values as 1 and 2. So in case of p1, the respective instance variable x and y will get updated with 1 and 2 respectively, and in case of p2, the x and y will get updated with the values 4 and 5 respectively, because we have passed these parameters to this parameterized constructor my point. So at first we are going to print this p1 and p2. When you are going to print this my point class objects, then underscore underscore str underscore underscore method will get executed, and it will print in this way. So let us go for the execution. You can find that it has printed 1 comma 2 within enclosed within first brackets, and then for this against this line it is printing 4 comma 5 enclosed within first brackets there, and print will leave one blank line here. Next, p1 less than p2. So p1 less than p2, it will be calculated, and it is returning true. Why? Because here we are having 1 square plus 2 square. What is the value? That means 1 plus 4, that is 5, and here we are having 16, that is a 4 square plus 25 square. So that is quite larger compared to this 1 square plus 2 square. So that's why it is returning true here. Now this particular operation can also be done using this underscore underscore lt underscore underscore method directly. So p1 dot underscore underscore lt underscore underscore p2, this p2 is getting assigned onto this other. This p2 is getting assigned onto this other in case of this add and this lt methods. So you see we are doing the same. Actually this line is very much similar with this line. So that's why this calling of this overloading function is same as this one, and also this line is also doing the same as this line is doing. So that's why we are getting the same output here, and in this way we have explained that how the operator overloading can be done in our Python and how to write the respective code. Thanks for watching this video.